So today's lesson is about applications. Applications that deal with arithmetic and geometric sequences and series. And so these are basically your word problems where you'll use the properties of arithmetic series or sequences. Same thing with geometric ones as well. And those are pretty much the easy ones because it's more of a matter of recognizing is it arithmetic or geometric and then applying the respective formula as needed. So I'm not going to do any examples actually on those types of problems, but what I want to do are the examples that deal with your financial ones, okay? And so some formulas from a sequence and series are also from exponential functions that I think at one time we might have covered, but I just want to make sure I touch on it again. And it's this formula right here, A equals P times 1 plus R over N raised to the NT, where P is your principal amount, the initial amount that you invest. R is your nominal interest rate, of course, always as a decimal. N is the number of times the interest is compounded per year. And it'll say that in the problem, such as being compounded quarterly, compounded semi-annually, et cetera, and each one of those compounding periods has a number associated with it. And then, of course, T is your number of years. This formula is not in your reference booklet. So we're going to look at two examples that deal with this particular formula, and then we'll look at one more example that deals with like using the arithmetic and geometric series type formulas. So this is a person deposits $1,000 in an account which pays interest at a 4% APR compounded quarterly. Now, assuming the person makes no additional withdrawals or deposits, how much will be in the account after 10 years? Okay, and so we know that we're looking at, we're trying to figure out what is A, okay? Because A represents that final amount, how much you have after a certain number of years being compounded a certain number of ways, okay? And so the 1,000 represents our initial deposit. And then it'll be 1 plus R, your rate, which needs to be written as a decimal. So 4% as a decimal is 0.04. N represents the number of times it's being compounded. Since it's being compounded quarterly, you have to think, how many quarters are in a year? Everything's based off of years, and so quarter will be 4. So you're going to divide it by 4, and it's going to be 4 raised to the T, which represents your time in years, which will be 10. Now, real quick before we solve this out, since T is always in a reference to years, you want to make sure that if you have a problem that says something like 9 months or a year and 6 months or something like that, you want to make sure that you convert those months into years. So we know that 9 months is 3/4 of the year. So we will plug in 0.75 for our T, and then a year and 6 months would represent 1.5 because 6 months is half of a year. Okay, and so basically from here we'll just plug everything in, and we'll figure out how much will be in the account after 10 years. And now the one thing you want to make sure of is that since we are talking about money, universally, money basically means we always do 2 decimal places. Okay. And so when we type this in and we get our answer, it's going to be $1,488.86. And it's as simple as that. Here's the next one. It says the population of a small town increases by 2% per year. If the population at the start of 1980 was 12,500, what is the predicted population at the start of 2020? So this one's a little bit different. This one doesn't deal with like your financial stuff, okay? But it still kind of deals with we have a particular population. It is increasing at a particular rate over a period of years. So this right here would be an example of geometric, because think about it, if we start out with 12,500, we would multiply it by 0.02 to figure out how many people it increased by, and then we would add that up. If we wanted to not have to multiply by 0.02, get our answer, and then whatever that is added to what we had before, the easier way to do it would be to take the 12,500 and multiply basically if you add 1 to your rate, especially if you're increasing, okay, whenever it's increasing, so 1 plus your rate, then the answer that you'll get will basically be the amount of people that you have the next year. Okay, so it kind of takes the initial amount, and then it takes how many people it increased by, and then adds them together automatically. And you can see that right here. Type this bottom line in, see what the answer is, and then do 12,500 times 0.02. Take that answer and add it to the initial amount, and then you'll see it's the same thing. Okay, and so since it says we're trying to predict the population at the start of 2020, well, 2020 is 40 years later. Okay, and so we're actually going to raise this to the 40th power. We're not going to raise it to the 40 minus 1 power because that the start was 1980, so that represents. You want to look at it, that kind of represents like year 0, the initial year. And so then it would technically be like 40 minus 0 instead, okay? And so we type that in, we'll get an answer of 27,600.496, so on and so forth. But realize that we are talking about people here, and so we can't have a fraction of a person, so we're looking at a population of about 27,600 people. So some of the problems that you're going to be dealing with when it comes to applications of arithmetic and geometric patterns are going to deal with compound interest and population growth. So compound interest is this whole application right here. Not application, I mean formula here of P times 1 plus R over N times N to the T. And then that last example we saw that dealt with population growth. Okay, so now we're going to look at this example, which talks about an application that deals like strictly with arithmetic and geometric series and sequences. And it says each day a runner trains for a 10-kilometer race. On the first day, she runs 1,000 meters, and then she increases the distance by 250 meters on each subsequent day. And so it says, on which day does she run a distance of 10,000 kilometers in training? Now, the one thing that you have to realize is that first off, you have differing units, okay? You have meters on one, and then you're trying to figure out kilometers. And if you remember anything about your conversions, King Henry died while drinking chocolate milk. I think that's the one that I hear the most from students. That that the conversion from meters to kilometers is, multiplying by 1,000. So 10 kilometers is actually 10,000 meters, okay? And so we are trying to figure out on which day does she run this particular distance. So basically 10,000 meters represents an nth term, an nth day, a part of the sequence. And so we're going to take that first formula of a sub 1 equals a sub n equals a sub 1 plus n minus 1 times d. Now, what is our d? D represents basically how much is increasing by each day, which is 250. Okay? So we plug that into the formula and we solve for n. We start by subtracting 1,000. Well, one way we can start is by subtracting 1,000, so that gives us 9,000. I'm sorry. I'm going to solve first by dividing by 250. That right there is probably going to be just the easiest for me because I am working right now without a calculator. And I cancel out the zeros, that gives me 36 equals n minus 1. So right there, n equals 37. So we know by the 37th day, she has finally run her distance of her 10 kilometers, which she was trying to accomplish. And now, so part B says, what is the total distance she will have run in training by the end of that day? And we want to give our answer exactly. Well, it says, what is the total distance? Total would mean sum, okay? So we're trying to find how far she, or the total amount that she did run as she's training for this 10-kilometer run. So sum. So we're basically looking at the sum of the 37 days it took her to train for this. Okay, so it's going to be 37 over 2, and then we can use either of the two formulas. For me, I'm going to use the formula, the shorter one, because I know what my first term is, which was 1,000 meters, and I know what my last term is, which is 10,000 meters, and I'm going to add them together and then multiply them by 37 over 2. So when I do add these together, I get this, okay? I know that 2 can go into 11,000, what's that, 550? 550? No. And then I'm almost multiply by 37. I'm gonna pause the video so I can do this real quick. So that is gonna be 203,500 meters. That is in meters. If you wanted to convert it to kilometers, you know, you just have to move the decimal place over to the left 3 spots. So then that would be 203.5 kilometers. And so yeah, your applications are pretty straightforward. You just got to know which formula to use and then go from there.